B, particles A and B of mass 2 kilograms and mass 5 kilograms respectively are, so first things first, B is definitely the 5 kilogram one because it has to pull the 2 kilogram one up it's a plane, by the way, guys. They didn't specify if this is a wedge, as in does the whole triangle move, so we're going to assume it doesn't. If it says wedge, it does. It should say a plane. Planes don't move, wedges do. Okay, the light and accessible string, so it's the same pulley, which means they have the same T value. Okay, that's all right. About 30 degrees is no bother. The point M lies on PQ, such that PM is 1 and PQ is 3. Okay, so one of them is 3 times longer than the other one. PR and PM are smooth, but PMQ is rough. So just this red zone here where we got to take in friction into account. When friction's into account, it will also affect the tension in the string, so we got to be aware of that. The system's released from rest with the string taut and initially accelerates, but due to the rough section MQ, B comes to rest as it reaches Q. So B equals 0, the velocity equals 0 when it reaches Q. If the coefficient of friction between B and MQ is K root 3, find K. Alright, let's completely ignore the red section to begin with and work on finding out what is the crack with the wedge before, what's the crack with the plane before that happens. So we're going to draw ourselves a large triangle here, and we're going to work out some gravity triangles. Okay, will help us solve this question. So we're going to start with a red triangle. This is 2G straight down, and then we're going to do parallel and perpendicular. So this is 2G in red. So this is 2G sine 30, because this is 30 degrees, but we don't need to worry about that too much just yet. So 2G sine 30. Sine 30 is a half, so it'll quite simply just be G. So 2 sine 30 is just 1, so it's just G. We don't need to worry about that. Okay, the next one is 2G cos 30, so 2 cos 30 will be root 3, so just root 3G for that. Root 3G. Next thing I'm on is the blue one. I'll do this a bit lower. Another gravity triangle over this side, so straight down, like so, and straight down and straight across. Okay, and once again it's 30 degrees, so we have 5G this time. So this one here, so that's 30 degrees, that's 60, makes that 30. Now 5G, so this is a 5G cos 30, which will simply be 5G cos 30, which would be 5 over 2 G. Oh, sorry, not 5 over 2 G, 5 root 3 over 2G. 5 root 3 over 2G, and then down here is simply going to be 5 sine 30, which would be 5 over 2G. Okay. So far so good. Next thing we got to worry about is the tension. So the T values going up and across, like so. So the T values, what are we going to do with them? Okay, let's start off with the 2 kilogram weight. The 2 kilogram weight is MA equals T pulling up the hill, and then it's a weight sort of acting against it. So it's going to be 2A equals T minus G. The next one's going to be 5A, which is going diagonally right down, and it's going to be its 5 over 2g, take away the t. Okay, now we can find out the common acceleration here. We can add them together and we get 7a equals 2.5g, take away g, which would be 1.5g, or 3 over 2g, and 1.5g, 3 over 2g, which is 9.8, is 14.7 divided by 7. Our acceleration is 2.1. Okay, so far so good. We're on a equals 2.1 meters per second squared, and we're matching said marking scheme, so we've done well so far. So we've got that part done, and now we're moving on that little bit further. Okay, so comparatively speaking, what we have to find out now is, if you imagine it's in the ratio of 1 is to 3. So P to Q is, let's for argument's sake, say broken up into 4x, from P going to Q. Or we suppose we can use 4D because the marking scheme uses 4D. So let's just use 4D, okay? This would imply that P to M is 1D and M to Q is 3D. Okay? Now we can find out how fast the 5 kilogram particle is going at the moment it hits the rough plane. Okay, so what we can do is UVAST for this, UVAST. Its U is 0, its V is what we're after, its A is 2.1, the distance it covered we said is 1d, and we might be able to get its velocity in terms of d, so we can get V squared equals U squared plus 2AS. V squared equals 2 times 2.1 times 1d. V squared equals 4.2d. V equals the square root of 4.2d. Now it enters the rough section, and this is where things change, unfortunately. Okay? So, in the rough section, we know that if we UVAST this again, UVAST, if we UVAST it, we know that our U value is square root of 4.2d. We know its velocity is 0, and it travels 3d more. Because remember, it travels, the red section would be 3d, and it says is that comes to rest as it reaches Q. So its final value is 0 as it reaches Q, and S is 3d. And what we can find out here is what deceleration what deceleration happened to it. So we can use V squared equals U squared plus 2AS. V squared is 0, U squared is square root that, which is just going to be 4.2d. 2AS is going to be 2 multiplied by A multiplied by 3d. Move it all over one side, and we get 4.2d minus 4.2d equals 6AD. The d's can cancel. So the d's cancel off both sides, and your acceleration is minus 4.2 divided by 6. I think it's minus 0.7. It's a 0.7 there, so minus 0.7. So minus 0.7 meters per second squared equals 8. Okay, so now we have the deceleration. So we're at this stage here. Now we have to re-examine what happens to the 5 kilogram particle. Okay, so remember F equals ma, and what was happening to the 5 kilogram particle is it's going downhill. So that's its 5g over 2 weight is forcing it downhill. Okay, it had its friction, it had its pulley, its tension T pulling it uphill. Now, do you know what I'm going to do as well? I'm going to go back to the original equations and I'm going to figure out what T is, just to see what the tension was at the beginning, because I'm just curious, okay? So see, at the very beginning of the question, we could have T equals 2A plus G. So T equals 2 times 2.1 plus 9.8. So T is 2 times 2.1 plus 9.8. 14 newtons, okay? So the tension used to be 14 newtons, okay? So just bear that in mind. Don't know if it's going to affect anything. Now, what we can say here is that the tension in the rough section, sorry guys, if we look at the 2 kilogram particle now, because remember, if the strings are linked together, they have a common acceleration. So the deceleration of minus 0.7 is actually the same for the 2 kilogram particle. So if we actually look at the 2 kilogram particle, which doesn't undergo the extra friction, we can find out what the T value is now. As I said, it was 14 newtons at the start of the question, but the T value has diminished as the 5 kilogram particle slowed down. So we have to find out what the new value of T is, okay? So here's what we could do. The 2 kilogram particle is still going uphill, and it's being pulled by the tension and then its weight, which is, I think we had it here, just G acting in the opposite direction. Now, this time its force is MA, which is 2, but then it has a negative, it's slowing down, so it has a negative acceleration, and that's T minus 9.8. So this implies that T equals minus 1.4 plus 9.8. The new T value is 8.4 newtons. Okay, then if we take the 5 kilogram particle, and we'll redraw the part of the diagram for this, because we understand this is quite a difficult question. So the new 5 kilogram particle is going downhill, okay, because of its weight, which is 5g over 2. But it's getting pulled up by the tension, which is 8.4 newtons. And it's also getting pulled up by friction, F underscore R. Now, how are we going to calculate FR? Well, we already know the downward force is 5 root 3 over 2g. Okay, so 5 root 3 over 2g. And this is the same going upwards, because remember, it's a plane, so it's not causing the plane to move. So friction equals mu n. I think, what's the mu value it alluded to earlier? The coefficient of friction is this much, find K. Okay, so we have to find the coefficient of friction. So mu equals K root 3. So mu equals K root 3. I'll deal with that later. I'm just going to go for this right now. So friction force is mu times N, which is 5 root 3 over 2 G. Okay. And tension is 8.4 newtons. So this should all link in. So MA, which is the force going downhill, equals its weight pulling it downhill, take away its tension, take away its friction, which opposes the motion. So MA, which is going to be 5 times, we know the A value to be, what's a minus 0.7. We know the weight to be 5g over 2. We know the tension to be 8.4. And then we know the friction to be minus mu over 5 root 3 over 2g. Whoa, that's a head full. So I'm going to move all this to the left. So we're going to get mu times 5 root 3 over 2g equals 5g over 2. Take away 8.4, and then 5 times 0.7 is minus 0.35. When you change it to the other side, it's plus 0.35. Going to throw all that into the calculator. So 5 times 9.8 over 2 minus 8.4 and then plus 0.35 is 329 over 20 equals mu times 5 root 3 over 2 times 9.8. So what I'm going to do here now is mu. Going to bring the 2. So I'm going to do 2 times 329. And then it's going to be divided by 20 times 5 root 3 times 9.8. And that is a crazy number, but we'll work with it. 2 times 329 divided by 20. I'm hoping it comes out as a third, otherwise I have a lot of work to do. 5 root 3 multiplied by 9.8. Once again, whoever created this question is absolutely crazy. Now that doesn't come out as a third at all, so it means I'm in trouble. So I'll have to break this down a bit the more the old school way. So 2 divided by 20 is 10. So 329 divided by 10. 10 times 50 is 50 root 3 divided by 9.8. Now I'm going to divide the 329 by 9.8 and see what happens there. (235 over 7). So it's 235 over 7 divided by 50 root 3. I'm sure they both have 5 in common. So 235 divided by 350. See that's 350 on the bottom. Is 47 over 70. So 47 over 70 root 3. Now let's see what the marking scheme has here. Now we're disagreeing. Why are we disagreeing? Sorry lads, my bad. This here is 3.5. See 5 times 0.7, that's 3.5. So this calculation has to happen again for me, I'm afraid. The joys of doing everything right and making a simple little mistake. So let's try this out again. 5 times 9.8 divided by 2 minus 8.4 plus 3.5, which is 19.6. I think this makes things a lot easier now. 19.6, bring the 9.8 underneath. This 9.8 goes underneath, the 2 goes above it, and the 5 root 3 goes below it. And what we're going to get here is 19.6 multiplied by 2 divided by 9.8 times 5 root 3. And we get 4 root 3 over 15. Okay, and we said at the very top is that it's k root 3. Mu equals k root 3, and this implies that k must equal 4 over 15. And we're done. Don't make decimal errors. Makes things a lot harder. Okay.